Welcome back, everybody. This video is going to be talking about solving inequalities. Now, it's important to know that when solving inequalities, treat them just like equations. You're trying to isolate the variable. But if you ever multiply or divide both sides by a negative, you must flip the inequality symbol. Okay, and the reason for that is it keeps the inequality true. All right, let's see if that happens here on these examples. First one, b divided by 2 is greater than or equal to -4. Let me rewrite that 4 first so maybe you can see how it looks from a fraction point of view. So b is being multiplied, or b is being divided by 2, so we're going to do the opposite of divide by 2. We're going to multiply by 2 on both sides. All right, notice I multiplied by a +2, so that rule does not apply. b is now by itself. b is greater than or equal to -8. Alright, and in case you were wondering what that looks like on a number line, here's a number line, -8, and -7's here, -9 is here. We're going to have a closed circle over -8, meaning we include that, and we shade everything to the right. All numbers to the right of -8, including -8, make the inequality true. Let's look at another one here. -3x greater than or equal to 39. X is being multiplied by -3, so let's do the opposite. Let's divide by -3 on both sides of the inequality. X is by itself. 39 divided by -3 is -13. But notice I multiplied, or I divided by a negative number. The inequality then needs to switch around. X means all numbers that are less than or equal to -13. Solve this inequality and make it true. Let's look at another one. Okay, this time we have multiple steps. -6 is greater than or equal to 10 minus 8a. a is being multiplied by -8, and we are also adding a +10. First thing we're going to do is get rid of that 10 by subtracting it on both sides of the inequality, much like if it were an equation. -6, -10 make -16. We still have -8a. Now we're going to divide both sides by -8. a is now by itself. -16 divided by -8 is a 2. Since we divided by a negative, we need to flip the inequality around. Alright, a is greater than or equal to 2. You don't have to flip it around, but normally inequality answers are given with the variable listed first. Any number greater than or equal to 2 makes the original inequality a true statement. Let's look at another one here. This time we have variables on both sides. Let's first try to get all the c's together. Notice we have 3 plus c equals 3 plus c less than 3 minus c. First going to add c to both sides. And then we have 3 plus 2c's. We're still less than 3. We're going to subtract 3 from both sides at this point, isolating the variable term. So it gives us 2c less than 0. And then finally divide both sides by 2. And we have 0 divided by 2, which is 0. c is isolated by itself. We did not multiply or divide by a negative, therefore we keep the inequality symbol the same. The solution to this inequality is any number less than 0 makes the inequality true. Let's do one more here. This time we have some simplification to do. We have to distributive property. Let's distribute this 3 to the y and the 5 to give us 3y plus 15 greater than or equal to 3y plus 8. Alright, let's try to get the variables to one side. Let's take away 3y from both sides, and look what happens. Something interesting happens. 3y's cancel. 3y minus 3y is 0. We're left with 15. and we're left with 8. And we ask ourselves, is this a true statement? Is 15 greater than or equal to 8? And yes, it is true. When that happens with inequalities, it means the end of the variable can be all real numbers. Any real number, any number for y will make this inequality true, no matter what it is. A positive, negative, 0, we're going to get a true inequality statement. Thank you for watching. I hope this clarifies what to do when solving inequalities.